Our journey begins at the edge of the solar system, beyond Neptune, where darkness reigns and mysteries abound. Here, icy remnants from the dawn of time drift in a vast, frozen expanse, once thought to be a quiet graveyard. But astronomers noticed something odd, distant objects moving in strangely aligned orbits, as if guided by an unseen force. This led to the bold idea of Planet 9, a massive, hidden world shaping the outer solar system. Yet, just as the theory gained momentum, new discoveries began to challenge it, revealing a far more complex and chaotic frontier. We now stand at the edge of everything, where two ghost worlds threaten to unravel one of astronomy's greatest mysteries. The mystery centers on extreme trans-Neptunian objects, or ETNOs, whose elongated orbits cluster in a way that defies randomness. In 2016, astronomers proposed Planet 9, a giant, unseen planet, was hurting these objects with its gravity. The theory was elegant, offering a single explanation for the strange alignment and igniting a global search. Each new ETNO discovery seemed to strengthen the case for Planet 9. But now, new evidence is emerging, evidence that could dismantle the entire hypothesis. The search for Planet 9 faces its greatest challenge yet. Science thrives on contradiction, and two newly discovered objects, ghost worlds, are shaking the Planet 9 theory. The first, 2017 OF201, follows an orbit that defies the predicted alignment, moving independently of the supposed giant's influence. The second, Ammonite, is a Sednoid whose misaligned path breaks the pattern once considered proof of Planet 9. These anomalies suggest the neat clustering may be an illusion or a local quirk, not evidence of a hidden planet. Instead of clarity, the outer solar system now appears more scattered and mysterious. Have we been chasing a phantom, or is the truth even stranger? The mystery deepens, and the search continues. Beyond Neptune lies the Kuiper belt, a vast disk of icy bodies, comets, and dwarf planets like Pluto. Among these, ETNOs stand out for their enormous elongated orbits, hinting at a complex architecture at the solar system's edge. When astronomers mapped their paths, they found a striking alignment, far too structured to be coincidence. The known planets couldn't explain this order. Something massive and unseen seemed to be at work. The peculiar orbits pointed to a hidden world, setting the stage for a revolutionary hypothesis. The Kuiper Belt's secret was a cosmic clue, waiting to be solved. In 2016, Michael Brown and Konstantin Batygin proposed Planet 9, a massive, distant planet shaping the orbits of ETNOs. Their simulations showed that such a planet could explain the clustering and stability of these distant objects. The idea was elegant, unifying multiple mysteries of the outer solar system. Planet 9 became a beacon for astronomers, guiding a focused search for this hidden world. The hypothesis offered clear predictions and a map for discovery. The hunt for Planet 9 was on, promising to reshape our understanding of the solar system. With a compelling hypothesis, the next step was to create a detailed identikit for this celestial fugitive. Brown and Batygin sketched a surprisingly specific profile of what Planet 9 might be like. They calculated it would need to be a substantial world, likely a super-Earth or a mini-Neptune, with a mass 5 to 10 times that of our own planet. The proposed orbit for this phantom planet is nothing short of extraordinary, a highly elongated and eccentric path around the Sun. At its closest point, it might venture to within 200 astronomical units of the Sun, more than 5 times Neptune's distance. At its farthest, it could swing out to 1,200 astronomical units. A single year on Planet 9 would last somewhere between 10 and 20,000 Earth years. Its vast distance ensures that it reflects very little light, making it exceedingly faint. Locating it would be like trying to spot a piece of coal against the black velvet of deep space. The origin of such a planet is another fascinating puzzle. The leading theory suggests that Planet 9 is not a native, but rather an outcast, violently ejected in the early solar system. The Planet 9 hypothesis ignited a global observational campaign. Astronomers redirected their telescopes, hoping to capture an image of this elusive world. The hunt became one of the most exciting quests in modern astronomy. Telescopes like the Subaru telescope became crucial tools. Scientists began meticulously scanning vast swaths of the sky. The search is a painstaking process, demanding immense patience. Images are compared to see if faint points of light have moved relative to the background stars. A planet will betray its presence through this subtle motion. This technique led to Pluto's discovery, but is now conducted on a far grander scale. Every new image could hold the key to a historic discovery. As the hunt progressed, the evidence in favor of Planet 9 seemed to grow stronger. Astronomers discovered more Trans-Neptunian objects whose orbits fit the predicted pattern. However, the universe is rarely so straightforward. Data challenges or refutes a prevailing theory. Astronomers knew that the case would not be closed until the entire population of Ethnos was better understood. The story of 2017 OF201 is not one of a real-time discovery, but of a quiet revelation found buried deep within digital archives. In May 2025, a researcher was meticulously sifting through archived images. Each digital image file contains a universe of information, capturing countless stars and faint, moving objects. Suddenly, among the terabytes of information, a faint signal emerged. This was the telltale sign of a distant solar system body. They had found a new resident of the outer solar system, its presence recorded but unrecognized until now. It demonstrated that some of the most profound secrets of our solar system are already sitting on our hard drives. It was a significant world, a potential dwarf planet. It became clear that this ghost from the data vault was about to cause a major disruption in the hunt for Planet 9. Once 2017 OF201 was confirmed, the next crucial step was to determine its physical characteristics. Based on its faintness and immense distance, astronomers estimated its size to be approximately 700 kilometers in diameter, roughly one-third the size of Pluto. This makes it a substantial world, a bona fide minor planet. Worlds of this scale can have their own geology, tenuous atmospheres, and perhaps even tiny moons. They are time capsules from the early solar system. What truly makes 2017 OF201 a celestial celebrity is not its size, but its extraordinary orbit. Its journey around the Sun takes an astonishing 25,000 Earth years to complete. At its most distant point, it travels to 1,600 astronomical units from the Sun, venturing more than 40 times farther out than Pluto. It is a true hermit of the solar system. The Planet 9 hypothesis predicts that a massive, distant planet should herd Trans-Neptunian objects into a distinct cluster with aligned orbits. But the orbit of 2017 OF201 doesn't fit. It's a glaring outlier, not aligned with the others. It moves as if Planet 9 doesn't exist. The orbit of 2017 OF201 is inconsistent with the Planet 9 theory. It's a powerful piece of counter-evidence, challenging the hypothesis. The discovery forced astronomers to reconsider their assumptions. The outer solar system might be a much wilder, more chaotic place than the Planet 9 model suggests. The emergence of 2017 OF201 was the arrival of a major problem for the Planet 9 hypothesis. It acts as a wrench thrown into the smooth machine of the Planet 9 hypothesis. 2017 OF201 is a gear that doesn't fit. The discovery significantly increases the noise, suggesting the alignment may be a localized phenomenon. This single object forces a cascade of difficult questions. Does this rogue world mean that Planet 9, as we envision it, simply cannot be real? Ultimately, the story is a beautiful example of science working exactly as it should. It does mean it must evolve or be replaced by a better one. It has shaken our certainty and reminded us that the cosmos still has many surprises in store. Just as the astronomical community was grappling with the disruptive orbit of 2017 OF201, another ghostly world emerged from the darkness. This new object, officially designated 2023 KQ-14, but nicknamed Ammonite, was discovered using the powerful Subaru telescope. This discovery was particularly exciting because Ammonite belongs to a rare class of objects known as Sednoids, which are central to the Planet 9 story. Sednoids are the true hermits of the solar system, defined by their incredibly distant orbits. The discovery of a fourth Sednoid was a major event, providing information about the dynamics of the outer solar system. Ammonite, however, had other plans, threatening to shatter the very pattern that had made Sednoids the poster children for the Planet 9 theory. Astronomers characterized Ammonite based on its brightness and extreme distance. Its nickname, Ammonite, pays tribute to its ancient orbit, evoking spiral-shelled marine fossils. The puzzle is the shape of its orbit. Sedna, 2012 VP113, and Lela Kunua had orbits grouped together, supporting Planet 9. Ammonite breaks this trend with a different perihelion and orbital orientation. This contradicts the Planet 9 model, weakening the theory that a single planet is responsible. Ammonite's orbit suggests more complex dynamics, challenging the simple picture of a shepherd planet. The discovery of Ammonite has sent ripples of doubt through the Planet 9 hypothesis. Before this finding, the alignment of the three known Sednoids was a statistical pillar supporting the theory. Now, with the discovery of Ammonite, that clean signal has become muddled. The pattern has begun to unravel. Ammonite's existence forces us to confront this uncomfortable possibility, that we built a beautiful theory on a foundation that may have been nothing more than a cosmic coincidence. The mystery of the outer solar system has not been solved. It has deepened, forcing us to look at the shadows with fresh eyes and wonder what other secrets are waiting to be found. To appreciate the impact of these discoveries, let's visualize the evidence for Planet 9. Imagine a map of the outer solar system. For years, this map showed a striking pattern. The longest orbits appeared herded together, pointing in a shared direction. This alignment was the bedrock of the Planet 9 hypothesis. But now, discoveries have shattered this picture, throwing it into disarray. They are significant contradictions that attack the very foundation of the argument. The story of a single planet herding icy worlds has been complicated by these rebellious objects. The pattern has been broken, forcing the astronomical community to reevaluate the evidence. 2017, OF201 and Ammonite disrupt the Planet 9 model in different ways. They are distinct anomalies that pull the cluster apart. Each attacks a different aspect of the orbital alignment. It is a 1-2 punch. 2017 OF201's orbit breaks the alignment in its angular orientation. It slices across the pattern at a dramatically different angle. Then comes Ammonite. Its primary deviation lies in its perihelion distance and inclination. Together, they stretch the cluster apart horizontally and vertically. It is harder to explain away two distinct types of outliers. The Planet 9 solution now requires complex modifications. With the once clear pattern now scattered and broken, astronomers are forced to confront an uncomfortable question. Was Planet 9 ever real, or a statistical illusion? The hypothesis was born from a pattern observed in a small number of objects. But as we find more objects, the picture is becoming less clear. This leads to the possibility that we were victims of observational bias. The pattern is not holding up as our sample size grows. This is a classic sign that the original pattern may have been a statistical fluke. We may have been chasing a phantom. But the simple solution of a single Planet 9 is now on much shakier ground. Is there even a significant alignment to begin with? Forcing us to wonder if we have been chasing a ghost all along. With the theory of Planet 9 facing challenges, the scientific community is revisiting explanations for the outer solar system's strange architecture. One compelling alternative suggests a fleeting cosmic visitor billions of years ago, a passing star. In its early days, our sun resided in a dense stellar nursery. A stellar flyby could have altered the fates of distant objects orbiting our sun. Its gravitational pull would have tugged and stretched the orbits of icy bodies in the protoplanetary disk. A passing star could have flung objects into elongated orbits and tilted their orbital planes. This theory doesn't require a hidden planet, but the memory of a long-gone star. Proving such an event is difficult, as the evidence is circumstantial. Another tantalizing possibility delves into the violent and chaotic history of our own planetary family. What if the gravitational shepherd wasn't a newly discovered Planet 9, but a long-lost member of the original giant planet club? Many models of solar system formation now suggest that our early system may have been born with more planets than it has today. It's plausible that there was once a fifth giant planet, an ice giant similar in size to Neptune or Uranus, orbiting between Saturn and Uranus. This forgotten giant would have played a crucial role in the early dynamics of the solar system before it was dramatically ejected. This theory, often called the jumping Jupiter model or variations thereof, posits that the early solar system was a gravitationally unstable place. The orbits of the giant planets would have shifted and migrated, eventually leading to a violent gravitational encounter. In one possible scenario, this fifth giant planet had a close brush with Jupiter or Saturn. The resulting gravitational exchange would have been catastrophic for the smaller world. It would have been flung violently outwards, like a slingshot, and completely ejected from the solar system, destined to roam interstellar space as a rogue planet. its existence would have been erased from our solar family, leaving only its gravitational signature behind. As this lost giant was being ejected, its immense gravity would have wreaked havoc on the distant disk of icy bodies that would later become the Kuiper belt. In its final departing moments, it would have scattered these smaller objects, flinging some into the Oort cloud and capturing others into strange, elongated, and inclined orbits. Precisely the kind of orbits we see with the Etnos. The clustering could be a fossil record of this ancient violent ejection event. The departing planet would have effectively kicked a group of objects into a similar configuration as it left the system. This theory elegantly explains the origin of the strange orbits without needing a planet to still be present. Like the passing star hypothesis, this explanation is compelling because it relies on processes that are thought to be common in planetary system formation. However, it also presents its own set of challenges. The ejection event would have to be modeled with incredible precision to see if it could reproduce the exact orbital clustering we observe, while also explaining the existence of outliers like Ammonite. It's a ghost story of a different kind, not of a visiting star, but of a banished sibling. The evidence is not a body we can find, but a pattern left behind by a planetary ghost that has been wandering the galaxy for billions of years. Perhaps the solution is not a single, large object at all, but a collective. A third alternative suggests the strange orbits are shaped by the combined gravitational influence of smaller, unseen worlds. This theory posits a massive, extended disk of material far beyond the Kuiper belt, a dense, inner component of the Oort cloud. This disk would be composed of countless icy bodies, maybe ranging in size from large asteroids to Mars-sized dwarf planets. Their collective mass, spread out, could be substantial. The combined gravitational pull of this swarm could act as a single cohesive force, gently shepherding the Etnos into their aligned orbits. This model provides a more distributed explanation for the clustering. The primary difficulty with this theory is detection. We might never be able to directly confirm the existence of this swarm. The mystery would be solved by proving the existence of a hidden swarm of worlds moving together in the darkness. The story of 2017 OF201 highlights a shift in astronomical exploration. Today, some of the most exciting frontiers are found in the bright glow of a computer screen. This represents a new paradigm in science, a digital gold rush. Modern observatories are immense data-generating machines, scanning the sky every night. This data is stored in massive, publicly accessible archives. This has transformed archives into active hunting grounds for new worlds. This allows scientists to re-observe the past with present-day knowledge. By reanalyzing old data, we can extract maximum value from scientific instruments. The great explorations of the 21st century will involve navigators of data. Intrepid digital explorers venture into vast archives to rewrite our understanding of the cosmos. This shift breaks down the walls between scientists and the public. The hunt for new worlds is no longer exclusive to those with PhDs. Thanks to open-source sky surveys, the digital gold rush is open to everyone. Anyone with a computer, internet, and curiosity can become a citizen scientist, mapping our solar system and beyond. Projects like Zooniverse's Backyard Worlds invite the public to search for new objects. Citizen scientists look for subtle movements that computer algorithms might miss. This technique has led to the discovery of thousands of brown dwarfs and planetary candidates. This collaborative approach is changing astronomy, accelerating discovery, and fostering a deeper public connection to science. The future of searching for distant worlds looks bright. We're on the cusp of a new era of observation, with next-generation telescopes surveying the sky with unprecedented depth. The Vera C. Rubin Observatory, under construction in Chile, will conduct a 10-year survey, photographing the southern sky. Its massive mirror and camera will produce a deep, high-resolution movie of the universe, a game-changer for finding Planet 9. The James Webb and Euclid telescopes can also contribute with their sensitivity to infrared light. The coming decade promises to be exciting for solar system exploration. The data will settle the debate over Planet 9, either finding it or ruling it out. The era of ghost worlds is ending, replaced by a clear map of our cosmic home. We began with the idea that a hidden ninth planet was reigning over the frozen darkness beyond Neptune. This phantom, Planet 9, sat on a theoretical throne built from the strange, clustered orbits of distant objects. It ignited one of the most exciting celestial hunts in modern history. But the arrival of two ghost worlds has shaken the very foundations of this throne. They are powerful usurpers whose orbits defy Planet Nine's gravity. They have smashed the neat pattern, scattering the evidence and casting a long shadow of doubt. The throne of Planet Nine is now crumbling, and the theory can no longer stand uncontested. We may have been chasing a ghost, a statistical phantom. This does not mean the story is over, but the beautiful simplicity of the original hypothesis is gone. The Phantom King has been dethroned. While challenges to the Planet Nine theory may feel like a setback, this is a moment of profound beauty and progress. The discoveries have transformed a straightforward mystery into something far deeper and more complex. This is the very heart of the scientific process. The discovery of objects that break this pattern is not a failure of science. It is a triumph. The outer solar system is now officially stranger and more magnificent than we imagined. It is a wild frontier, likely shaped by a multitude of forces. This newfound complexity is a source of awe and inspiration. The puzzle is now harder, but the potential rewards are far greater. So where do we go from here? We must continue the journey into the dark. The answer to the puzzle of the outer solar system lies waiting for us in the faint, cold light of its most distant residents. Our task is to gather more of that light, to find more of these ghost worlds, and to build a map so complete that the true architecture of our cosmic neighborhood finally reveals itself. The next decade promises a revolution in our understanding, powered by a new generation of technological eyes. The Vera C. Rubin Observatory will soon begin its relentless survey, creating the most detailed motion picture of the universe ever made. The outcome will be a profound victory for human curiosity. We are the generation that is finally exploring the last great frontier of our home in the universe. In understanding the secrets of these distant, icy worlds, we are ultimately learning more about the improbable and precious nature of our own.